Okay, everyone, welcome to the video lecture on the analytic geometry. Today's topic would be on circles. Okay, so for the objective for this topic, we have the following. We have number one, we are to define a circle, the center of the circle, the radius of a circle, the diameter. Next is to identify the standard and general form of the equation of a circle. And number three is to solve for the equation of a circle where radius and or center is are not given explicitly. Okay, so to start off the discussion, we have first the uh, standard form of an equation of the circle. So let us define first what is a circle. A circle is a locus. A locus is simply a word for collection, a collection. Circle a circle is a locus or a collection on a plane whose points are all equidistant from a fixed point known as the center. So if we're going to draw a circle, of course, starting with from the center of a circle, any point along the circle is always equidistant, meaning is of all equal distances from the center of the circle. And the point of the center, which is of course the center, and the distance from the center to any point on the circle is called the radius of the circle. Okay, so as we can see as in this example, the center is represented by the point 2, 3, and the distance from the center to any point along the line of the circle is 3 units. So this 3-unit line is or serves as the radius of the circle. Okay, so for this example number 2, the standard form of the equation of a circle, we have the center at the origin, so 0, 0. You have 0, 3 as a point on the circle, which is also on along the line. So the question is, what is the radius of the circle? The radius of the circle is actually 3 units. Okay, so to further understand the succeeding topics, I will be defining a few terms in addition to what was already defined as the definition of the circle and the radius. Okay, so common terms that we will encounter eventually are the chord and the diameter. Okay, so let me first define what is the diameter. The diameter is more um, uh, commonly popular as compared to a chord. So let's first discuss the definition for the diameter. The diameter is actually the distance which is twice the radius of the circle. It is the distance from one point on the circle passing through the center of the circle and ends up to the other end of the circle, continuing in a straight line. So that means if the distance from the center of the circle to any point is the radius of the circle, if you have two radii of the circle that is forming a straight line, this distance is actually called the diameter of the circle. Now, for the chord, a chord is simply sort of diameter, but actually the chord of a circle does not pass through the center of the circle. Okay, so it is simply the straight line distance from any given point. The chord is simply a line segment that passes through 2 points on the circle, but does not pass through the center of the circle. So that is a chord. Okay, so in this example we have presented to you a while ago, we have the figure of a circle at the center 2, 3, and the distance or the radius of the circle from the center of the circle on this point is 3 units, thus its radius is equal to 3. Okay, so also we have this equation of the circle. We have another circle. What is asked here is what is the radius of the circle whose center is at the origin and passes through the point 0, 3. Okay, of course, the radius of the circle is actually 3 units. Okay, so let's proceed with the equation of the circle, which is of two forms. One is called the general form, and the other one is called the standard form. Now, the general form of the circle has the form ax squared plus ay squared plus dx plus ey plus f is equal to 0. Now, what we see here is that ax squared and ay squared are the, or x and y that appears here are the variables that represents the ordered pairs on our Cartesian plane. The circle has the degree 2. That is why x here is of the form x squared and y is of the form y squared. So this means that this is a second degree equation. Therefore, the circle is actually a quadratic equation because the highest degree of our variables in our equation is degree 2. Therefore, this is of the form of a quadratic equation, and the condition for which is that a, or the coefficient for ax squared and y squared, it should not be equal to 0. Now, for the standard form for an equation of a circle is given by this equation, which is x minus h square plus y minus k square is equal to r square. Now, h and k serves as the coordinates of the center of the circle. So where c, or the center, hk is the center, and and r is the radius of the circle. Okay, so if we're going to specify a point P which has the coordinates x, y to be a point on the circle, in order for us to compute the radius of the circle, we simply get the distance between the point P with the given coordinates x, y from the center of the circle with the coordinates HQ. We have already presented in one of the video lectures on the distance formula. The form of computing for the distance between 2 points. So this is the form of the distance formula, but if we're going to apply the given coordinates and the symbols for r, for the coordinates of c and the coordinates for p, the distance formula will have this form: r is equal to square root of x minus h squared plus y minus k squared. Of course, if we're going to square both sides, we will have r squared as equal to x minus h squared plus y minus k squared. Expanding the equation leads to the general form of the circle. Okay, so let's take a few examples. Solve for the standard and the general form of the following circles. Draw the circle afterwards. Okay, so for number 1, we're given the center as at point -1, 0 with a radius 4. Okay, so making use of the general form or the standard form, we have x plus 1 square plus y square is equal to 16. So how did we arrive with the this form of the equation? Remember our standard form, it has the form r square is equal to x minus h square plus y minus k square, where r is the radius of the circle and h and k are the coordinates of the center of the circle. Okay, so since we are given the radius r, in our general form r squared, this becomes 4 square for our example number 1, so that becomes 16. So we have 16 here. Now for the center of the circle, we have x minus h, y minus k. So h and k serves as the coordinates of the center of the circle. So we have -1, 0. So that becomes x minus -1. So that becomes x plus 1. Then k would be 0. So that becomes y minus 0. That becomes y, then square. So simply we have x plus 1 square plus y square is equal to 16. Now, to convert this into the general form, what we need to do is to expand the square of the given binomials, or the given binomial x plus 1. So we're doing that. We have x squared plus 2x plus 1 for the expansion of the binomial of the square of the binomial x plus 1. Then we have x squared plus 2x plus 1, then plus y squared is equal to 16. So rearranging this according to the pattern of the general form, so simply we have x squared plus y squared plus 2x minus 15 equals 0. Okay, so to the drawing of the circle correspondingly will have this figure. The center is at negative 1, 0. The radius is at 4. So that means from the center of the circle, this should be 4 units. This distance should be 4 units. So of course, from here to the origin is equal to 1 unit, and from the origin up to this point should be 3 units to make 4 units. So this is actually 4 units. Okay, so let's have example number 2. Example number 2, we have the center at 4, 2, and the radius at equal to 1. Okay, so substituting the values of the center of the values of h and k, 4 and 2, and the radius in our standard form, we have x minus h, which is 4, y minus k, which is 2, is equal to 1 square, which is 1. So this becomes x minus 4 square plus y minus 2 square is equal to 1 as the standard form of the equation of the circle. Now, to convert this in general form, just like what we did in the first example, what we need to do is to get the square of the given binomials. So x minus 4 squared gives us x squared minus 8x plus 16. Y minus 2 squared gives us y squared minus 4y plus 4, then equals 1. Rearranging the terms and combining like terms, we should arrive with x squared plus y squared minus 8x minus 4y, then plus, this is 16 plus 4 gives you 20, then transpose 1 to the other side gives us negative 1, so that is 20 minus 1 gives us 19, then equals 0. So this is the general form of the equation of the circle for example number 2. This is the general form, this is the standard form. Now, to draw the circle, the circle has the center at point 2, 4. The center at point 4, 2. Okay, so the center is point 4 and 2. So this is the center of a circle, and the radius of the circle is 1 unit. So therefore, if we're going to draw the circle with this unit is actually 1 unit, and correspondingly this point here is actually 3 and 2. Of course, this point here, if we're going to draw or specify the point at this location, this is actually 4 positive 3, positive 4 positive 3. This point here would be 5 positive 2. This point here would be 4 and positive 1. Okay, so let's take on example number 3. So for example number 3, we have the center at 3, negative 4, and the radius equal to 5. Okay, so for example number 3, again, our center of the circle is at 3, negative 4. So in our substitution, this becomes x minus 3, then y minus negative 4, that becomes y plus 4. And the given radius is equal to 5, so 5 squared becomes 25. Okay, so this is the standard form. Now the general form is that, again, we're going to get the square of the given binomials. So this becomes x minus 3 squared. This is given as x squared minus 6x plus 9. Y plus 4 squared becomes y squared plus 8y plus 16, then equals 25. Okay, so combining like terms and rearranging the terms according to the arrangement of the general form, we have x squared plus y squared minus 6x plus 8y. Then, of course, this becomes 16 plus 9. 16 plus 9 gives us 25. 25 minus 25 gives us 0, so this becomes 0. Okay, so drawing the circle is at point 3, negative 4. 3, negative 4. Now, the radius of the circle is 5 units, so if we're going to draw the line from positive 3, drawing 5 units towards the right, we should end up with at point 8, so that is 3 plus 5 equals 8. So therefore, this point here would be equal to 8, negative 4. This point here would be equal to positive 3, then negative 4 plus 5 units gives us negative 9. So this means this point here directly straight downward from the center of the circle, this is actually 3, negative 9. Okay, so this point here is actually 3, and having this as 5 units, this would be 4 units plus 1 unit. This becomes 1, so this becomes 3, positive 1. And finally, this point is actually negative 4. Our y is equal to negative 4, whereas the x component would be, this is 3 units. So to make 5 units, we need to have an additional 2 units here. So this is actually negative 2. So this point, which is directly along this line, is actually negative 2, negative 4. Okay, so for the last example, example number 4, we have the center at 5, negative 1, and the radius is equal to 7. Okay, so the standard form of the equation for the circle with the points 5, negative 1, that becomes x minus 5 and y minus negative 1, or y plus 1. Okay, so this becomes x minus 5 square plus y plus 1 square, and given radius is equal to 7, so 7 square gives us 49. Okay, so doing the same solution for getting the general form, we have x minus 5 square plus y plus 1 square is equal to 49. Squaring the two binomials, we have x squared minus 2x plus 25, y squared plus 2y plus 1 is equal to 49. Then rearranging the terms, this should be equal to x squared plus y squared minus 10x plus 2y. Then 25 plus 1 gives us 26, minus 49 gives us negative 23 is equal to 0. Okay, so drawing the circle again is at point, the center of the circle is at point 5, negative 1. So 5, negative 1. Now, drawing the circle with the radius of 7 units, so this becomes 5 plus 7 units. This point is actually positive 12, and its y would be negative 1. So this point is 12, negative 1. Now this point here, which is in the direct opposite of this point on the other side of the circle, this point is actually, this is 5 units. So to make 7 units, we need to add an additional 2 units. So therefore, this is actually negative 2 to make this 7 units. So this means this point here is actually negative 2, negative 1. Okay, so from the center of the circle towards this point that is directly above our point 5, this point here should have the coordinates 5, and this should be 6, since this is already 1 unit. So to make 7 units, this should be 6 units to point the exact point here above our center of the circle. So this point directly above is actually 5 positive 6. Okay, so lastly, the point directly below the circle is actually the point 5 and 5 negative 7. So to make 7 units from negative 1, we have to add 7 units. So this should be negative 8. So let me correct that. This should be negative 8. This is 5 negative 8. This point here. Okay, so let me present to you the conditions to determine a circle. Aside from the radius of the circle, some other sets of information can also determine a circle. This includes 3 distinct points on the circle, the center and a point on the circle, the center and the diameter of the circle. But all of this set of information still boils down to solving for the center and the radius of the circle, and then solving for the equation of the circle using standard form. So for example, we have 3 points. The following example shows to solve for the equation of a circle given 3 distinct points. So for example, we are given the points 5 negative 1, 6 and 2, and 1 and 7. So what is asked here is to solve for the equation of the circle. So let's go through with the given examples. Okay, so we'll let HQ be equal to the center of the circle, and of course R is equal to the radius of the circle. The standard form for the equation of the circle is given by x minus h square plus y minus k square is equal to R. Now, since the circle passes through the points 5 negative 1, 6 2, and 1 7, then we then have the 3 forms of the equation. In standard form, we have 5 minus h square, negative 1 minus k square is equal to r square. 6 minus h square plus 2 minus k square is equal to r square. 1 minus h square plus 7 minus k square is equal to r square. Now remember, the given 3 points are on the along the line of the circle, and therefore, if we're going to measure the distance from the center of the circle towards any of these points, that distance is actually equal to the radius of the circle. That means r square here is the same all throughout the 3 equations. Now, if we're going to expand each of these equations, we have the following. 5 minus h square, negative 1 negative k square, we have 25 minus h 10h plus h square, plus 1 plus 2k plus k square is equal to r square. Rearranging this in its general form, we have h square plus k square minus 10h plus 2k plus 26 is equal to r square. Okay, so what I have described to you is the same process that was described to you earlier in the early example. So doing the same for the second equation, we should arrive with this form of the equation. Also, for the third equation, we should arrive with this form of the equation in general form. Now, after you are done with expanding and expressing the forms of the equation in general forms, you will have 3 forms of the equation. Now, the next step is to rewrite the equations in this form so that we should be able to do some eliminations. Now, of course, this form of the equation is the same, meaning equation 4 is the same as equation 5 is equal to equation 6. This means we could equate either equation 4 to equation 5, equation 4 to equation 6, or equation 5 to equation 6. So what is presented here is we have equated equation 4 and 5. So we have negative 10h plus 2k plus 26, negative 12h minus 4k plus 40. This would serve as our equation 7. Then we have equated also equation 4 with 6. So we have this form of the equation, and let us call this as equation 8. Now, the next step is to simplify equation 7 and equation 8 in the order of elimination or substitution or simultaneous equation using solutions to linear equations. Now, if we're going to simplify further equation 7, what we need to do is to transpose negative 12h to the other side, and negative 4k to the other side, transpose negative 26 to the side of 40. So what happens here is you have 12h positive minus 10h, that gives us 2h. And 2k plus 4k gives us 6k. Then 40 minus 26 gives us 14. Next is we have transposing negative 2h to the other side. This becomes negative 10h plus 2h gives us negative 8h. Next is 2k plus 14k gives us 16k. Next is 50 minus 26. 50 minus 26 is 24. Now this will serve as our equation 9 and 10. Now the next step is to eliminate one of the variables h and k. So doing the process of elimination, well, obviously what we can do here is that it is easier to eliminate h. Choosing between h and k, it is easier to eliminate h simply because we could actually simply multiply the equation 9 by 4 to make this 8h, so that it would have the same and same coefficient as the as equation 10, but opposite in sign. So what we can do is to multiply equation 9 by 4, so that becomes 8h plus 24k plus 56 is equal to 56, and 14 times 4 gives us 56. Okay, so combining now equation 11 with equation 10, so we have actually we can add these two. We can eliminate actually h. Then we can have 24 plus 16 gives us 40, and 56 plus 24 gives us 80. So that becomes 40k is equal to 80. We can now solve for k. K is equal to 2. Then going back, since we have already solved for 2, we can now actually solve for h. Solving for h, we could choose any of the given equations above. What is used here is equation number 9. So we have 2h plus 6k equals 14. Substitute the solved value for k. So we have now 2h plus 12 is equal to 14. 14 minus 12 gives us 2. H is equal to 1. So therefore, the center of the circle is actually at point 1, 2. So therefore, we can now solve for the radius of the circle given the center of the circle. So we have 5 minus h square is equal to negative 1 minus k square. If we're going to make use of one of the equations, original equations, so what was chosen here is equation number 1. So solving for r, we have 5 minus h square minus negative 1 minus negative k minus k square is equal to r square. Substitute the values of h and k in this given equation. We have 5 minus 1 square. We have negative 1, negative 2 square. So this becomes 5 minus 1 is 4 square becomes 16. Negative 1, negative 2 becomes negative 3 square becomes positive 9. And this becomes 16 plus 9 gives us 25. R is equal to 5. So therefore, the general form or the standard form of the equation given the 3 points originally in this example will have the equation x minus 1 square plus y minus 2 square is equal to 25. Remember what we have computed for h is 1 and k is equal to 2, and the point hk or point 1, 2 is the center of the circle, and the radius is equal to 5. 5 square gives us 25. Okay, so I'll be cutting the discussion. This would be the end of part 1 on the discussion of circles.